Hello, everyone. Welcome to Data Engineers Lunch number 21. We are almost halfway through 1 year's worth of Data Engineers Lunches. So thank you, everyone, for joining us and continuing to be with us on this journey. Today's topic is going to be on Python ETL tools. And the speaker for that is going to be Obi, and he's an engineer here at Anant. Currently, the main co-organizer for this event is Rahul. Rahul is looking for co-organizers, and essentially what you would do as a co-organizer is help spread the word and help get sponsors. And if you're interested in being a co-organizer, you can reach out to Rahul at rahul@anant.us. We are a part of Data Community DC, which is a diverse community of organizations and meetup groups. No matter your race, creed, gender, we are an inclusive community. So always feel free to come. And Data Community DC is also made up of a bunch of different other groups. We have Data Viz, which is always having events, statistical seminars, full stack data science DC, us Data Wranglers DC. So if you're interested in any of these other organizations, meetups that fall under the Data Community DC umbrella, you can find out more at datacommunitydc.org, and you can find events that these other organizations are holding either on Meetup or events.datacommunitydc.org. So what do we cover here? We essentially cover anything data engineering. So if that includes data cleaning, data processing, ETL, taking data from an ingress, egress, what do data scientists need? We prep that data. So how can we do that using data engineering? A lot of the things we've covered so far are just high level data structures, as well as some command line tools that can help make your lives a little bit easier. And we continue to walk through the data engineers roadmap and to provide you a walkway of what you can learn and study and become a full-fledged data engineer. This is generally when we're in person, we have a couple minutes where you get up and go speak to someone new that you haven't necessarily talked to before. But currently, since we are a virtual event because of COVID, if there's anyone new that wants to say hi and what they're doing with data engineering, or hope to potentially get out, or even if there's something you can present on. I won't pick on anyone since we have a good amount of new people here, but if you are interested in just saying hi, hello, and what you work with data engineering, or potentially what you could present on, you can go ahead.
Hi, my name is Lisa Hallman, and I just am newly, I've just got my new AWS Solutions Architect Associates. And I'm looking to actually move in the field of data engineering because I spent 22 years as a biostatistician. And so I'm wanting to know what it would take to become upskilled and fully functional as a data engineer. If there's any topics that I think I could present on, I would like to. Thank you.
Yeah, great. Yeah, if you're interested in talking about anything AWS wise or something related to that. So if you want to learn something and then present on it, you can do that as well. And you can drop an email either to rahul@anant.us, or you can drop it to me, and we can hopefully get you in the queue somewhere. And I'll go ahead and drop those emails in the chat. Great. Pleasure having you, Lisa. Anyone else that wants to say hi? All righty, I won't pull any teeth.
Hi, my name's Mike. I'm with the Statistical Seminars DC. I was just telling everybody hello. I might have an event, might have a work or a talk to give a Rahul in a couple weeks. But I'm having an event this Thursday. If anybody's interested, it's on Strings and R. I just posted in the chat. Or you could connect with me on LinkedIn.
Great. Thanks, Mike.
Thank you.
So group rules, generally, if you have a question, don't hesitate to ask. Because we are a community here. The more knowledge you have for a particular subject will help everyone grow their internal knowledge. Generally, be polite and courteous to others. If you have a question when a speaker is talking, depending on the speaker, they may have preference in terms of if they prefer you to ask it in chat, and then they'll get to it when they get to a good stopping point, or you can just go ahead and speak up. But depending on the speaker, they'll have their input at the beginning of the presentation. And again, share what you know with us. This is a community, so don't hesitate to reach out or to speak up if you know something. Here at Anant, we work on global data analytics platforms surrounding technologies such as Cassandra, Spark, and Kafka. So data engineering plays right into what we do on a daily basis. DataStax is a partner and a sponsor for this event. GW University is also a sponsor. So when we have in-person events, usually GW helps us provide venue space so we can meet in person. We have a couple institutional and organizational sponsors. And then here we have any announcements that someone would like to speak up. So if you're looking for a job or if you're offering a job, you can go ahead and speak up or drop it in the chat so people could see. Like Mike, if you have any meetups or events coming up, you can again speak up or drop it in the chat. Again, meetups or hackathons or conferences or classes. All right. Some upcoming events that we have for this specific data engineers lunch. We have Will, I think he's on the call, or he was, but Will is giving a talk on Prometheus next week. And Rahul will also be giving a talk on Thanos, I believe, the week after. And then we also will be putting up the updated topics for May on the Eventbrite or on the meetup page. So you'll be able to find them probably this week for what's coming up for the next month. All right. And with that, we will pass it over to Obi. And Obi, it's all yours.
All right. Give me a second to get set up. Share screen. Let's get the chat right away. So I am Obi Anaminachi, a junior engineer at Anant. I've been working here for about a year now. Today I'm talking about Python ETL tools. Python is sort of generally my language of choice because I like to do machine learning stuff, and sort of having ETL tools ready to go alongside that for things like your data pre-processing and cleanup are useful things to have. So today we'll be talking about a couple of ETL tools in general terms, what they're like, what they can and can't do maybe. And the idea here is to set up a bunch of future talks where we go into each one in a little bit more detail with demos. So starting off, just ETL in general stands for extract, transform, load. They help, the tools specifically are for helping you set up your pipelines. So they handle your connections to where your data is, databases or file types that you can interact with normally with base Python, or you want them to help manage those interactions to accomplish the extraction and loading of data. They have resources for specific data transformations. They might have an internal data representation in order to facilitate that type of stuff, but it's possible you might need to sub in another one or use inbuilt Python capabilities in order to do that. They can manage the order of your steps within the pipeline. beyond just like writing down in order what happens in your code. But they can accomplish a number of steps, running them in order when each one is completed. Sometimes they schedule the running of those pipelines, and they often manage your computational resources so that your jobs run quickly, often by running steps in parallel on the same computer or distributed out to a set of computers when you're using distributed applications. So the tools that we're going to talk about today are Pygram ETL, PETL, Pandas, Bonobos, PySpark, Airflow, and Luigi. And I'm grouping those last three because they're sort of things that we've talked about here before. So we talk about Spark a good number of times. Just comes up because we do a lot of Spark here, and distributed data processing is something that we have recently talked about a lot. And then both myself and Will Angel has given talks on Airflow, and I've also given one on Luigi. We'll go into a little bit of detail about those, but not too much because they have their own content. So starting off on our taxonomy, Pygram ETL, it contains classes for filling fact tables, which are their internal data representation. And they have their own classes internally for manipulating those, for doing data transformation, the transform step. And then also they have connections to external databases and file systems in order to do your extract and your load steps. So the way they talk about it is what classes you would use for those sort of things. You have data sources for access to your different data sources, your databases, your file systems, your APIs. You have tables for giving access to those, like to that stored data. You can parallelize on a single machine. This is not a distributed system. It's parallel on a single machine. And it also uses Jython connection wrapper that they're talking about now, so that you can also use your Java classes with this ETL tool. The individual processes within your pipeline are defined as steps, and then it also offers you your first in, first out dict in order to determine more so than the like ones that are available in base Python, the order of processing. And then PETL is another one. It has integrations with a bunch of data sources and sinks, SQL Alchemy, Pandas. Wow, that is hilariously spelled wrong. I'm pretty sure that should say NumPy. And it integrates with Excel files, CSV, all this sort of stuff for loading and extracting your data. And it has transformations for getting subsections of your data, converting and filtering your data via user-defined Lambda functions, the actual inbuilt Python Lambda functions. But you can use them alongside this to map and filter and all that good stuff. You can do regex matching and joins. So you can do a bunch of data processing with this, and it does have integrations with a good number of data sources and sinks, but maybe not as many as you might want, maybe not the specific ones that you would want. So Pandas, another open source. Well, it's not necessarily an ETL library, like it wouldn't advertise itself as one, but it's a sort of data structure and data analysis tool. And its main defining feature is the data representation. It emits data frames. You can load data into Pandas data frames from CSV, from other Python types, but it does not have the ability to go out and connect to various databases that you might want to get data from. You can load data from Pandas. So if your data is in a Pandas data frame, you can export it out to a number of other formats, including CSV, Pickle, which is Python's representation. It's a serialized object representation, sort of similar to JSON. You can export it to HTML, and you actually can export it to certain databases via CQL export. Why did I say CQL? Got Cassandra on the brain, SQL. And then you can transform data that's in data frames via group by, drop null, drop nice to drop null in a category. You can drop duplicates, you can filter, you can merge, you can join, all that sort of stuff, all the sort of processing features that you might want. Pandas can help you do that. Bonobos is an ETL library for Python. It streams data, and that's going to have, we're actually going through a Bonobos example a little bit later, and that's going to have consequences there. But it mostly does processing one row at a time. And it's for targeting small scale data, small jobs, not big data. So if you have like 60, 80 gigabytes of data, Bonobos might be able to handle it. But if you have much, much more, you would probably want to use something else. So Bonobos is mostly a framework for packaging your other Python code in a way that will run properly for your ETL like pipeline. So it mostly just makes and manages that pipeline, and the actual defining code has to come from you. And whether that's using your standard Python types and running with that, or using some other data representation like the pandas in order to get some of that extra processing, that's up to you. Some of the tools that we have discussed previously on Data Engineers Lunch, PySpark, which is the Python shell and API for Spark, which is a distributed analytics engine, which means it runs on multiple computers at the same time. If you were running into the sort of size limits on Bonobos that I mentioned just a second ago, probably recommend you switch over to use Spark. Or some other big data distributed analytics engine. It also has an internal data representation called data frames that enables your processing, joins, group by, filters, all that sort of stuff. As a sort of descendant of MapReduce. Airflow is a Python workflow schedule. It also runs DAGs, directed acyclic graphs of tasks. So like Bonobos, you define your order of run, all that dependencies and all that sort of stuff via graphs. And Airflow is also a scheduler, so it can schedule their execution using sort of cron syntax. If you want a job to run every day or every 2 days or every month or every minute, Airflow can handle that sort of stuff. And it has methods for defining the data paths between tasks, but I don't think has an internal data representation in order to help with ETL. So you would be managing the data and the transformations that actually need to happen with other Python code. And then Luigi is a Python package for managing pipelines of batch jobs. So Luigi also has a sort of DAG interface. You set up your tasks and graphs with their dependencies, and then data generally gets passed between your tasks in files, but they have special sort of input and output nodes on the graph that act as connections to different databases and different file types and the places where your data probably actually is, rather than it having to be in files already. And it does not contain its own data representation to help with your transform step. You would have to do that yourself as well. All right, so we're moving on to the demo in a little bit. If there are questions, this is the time for them. It's fine just to speak up, but if you want to put them in chat, that is also fine.
Well, I do have a question. So you had mentioned that PySpark can handle data sets that's extremely large. Mm-hmm. So how does that work? Is there like a does it like break down the data set somewhere, or is the data set actually stored in like a temporary spot, maybe a cloud or something?
Yeah, so the way that Spark works when you set up your environment for that is that it's already a distributed software. It goes on a bunch of different computers. You set up your master node and you set up your worker nodes on a bunch of other systems. And then your master node, when it is like preparing to execute your code, it will split that up into individual tasks, define which data goes with each task and sort of bundle that together and send it out to the workers. So each of the workers that need specific data will have that data, but it's not necessary for the data to be copied specifically to each node that wants to work on stuff.
Yeah, so Spark there distributes it over multiple machines, whereas Pandas only has support for a single machine.
Yeah.
Though that said, oftentimes just getting a bigger machine is a good solution to memory limits.
That's fair. All right, we're going to hop into a Bonobos example now. So I'm running this in Gitpod, which if you have Gitpod already open up, you can literally hit this button and get in. Once this is set up, I've modified the Docker file that builds this to install GraphViz because we need that. But I have not actually had it install Bonobos. So if you're using this on Gitpod, once it opens up, you'll just want to run pip install Bonobos. And also probably pip install GraphViz. You'll need the Python section interface in order to have your pipelines interact with GraphViz so you can actually see the graphs. So the first thing we're going to do once we have all that installed is we're going to look at their simplest tutorial sort of pipeline first. So that's bonobo init tutorial.py. So we'll just literally generate your Python file. And if you look inside, there's actually only like maybe 10 lines of code here. There's a lot of space and placeholder comments, but you can see that it's using generators. The way that you define your individual snippets of code, your individual like nodes inside of Bonobo, is to set them up as functions or potentially as classes if you want to have them contained within each other. If you want to have related code grouped together, you can also define them in classes. So all this does, the extract yields hello and world in separate, in order, in separate little packets. There is a transform, which doesn't really do anything. It gives you back the arguments that you used to call it, but we don't really use any. And then load, in this case, just literally prints them out. So down here in the get graph method, we define our graph, just first create the object, and then we add our chain, the only one that exists for this graph, which runs the steps extract, transform, load as defined up here. And then it returns the graph. There's get services function here that we don't actually use because we're not integrating any outside services. And then there's their main, which just runs your graph. So if you want to run this, it's actually very simple because you can just say Python tutorial.py. There aren't even any actual arguments here. And when it runs, you can see it prints out the correct things. And then it has a sort of description of what state of the pipeline you're in. This one finishes too quickly for you to actually see it updating, but you can see the name of the step, how many inputs are coming in, how many outputs are going out for each step. So you can see the first one is just a source. It takes in the arguments for that like node and outputs hello and world. The transform step gets those inputs, hello and world, from the first step and outputs them basically unchanged. And the last step gets those two inputs and prints them out. And does not output anywhere. It is possible for your load steps, even the ones that connect to services, to do output to, say, a SQL server. You can have those have outputs beyond that and actually go into other nodes and continue doing processing. But you don't necessarily have to. It's optional. So we can see that run, and then we can also, if we say bonobo inspect graph tutorial.py, and then we're using the graph viz sort of stuff here, .-png, to export it as a PNG. So we run this, it outputs our PNG. It's going to be extremely simple because this is a linear graph with 3 steps. You have extract, transform, load. So that's pretty easy. And here is a slightly more complicated one. So you can see there's a couple more imports added. Not a huge amount necessary. So originally this used a sort of open data source thing. I started out with one of their own tutorials. This one, Python ETL tool to transform deeply structures to tensor. Okay, so what was I saying? Oh yeah, this used in open data source, which is sort of defunct. They've removed the public option for that. So I've substituted in some of our own code, which I might end up changing later. But what we're doing is we have our first extract step that gets data out from an API. We have we're defining a context here, which is with this output.txt file open. We have this step that doesn't do anything because it's actually a sync for data from 2 separate sources that we want to put together, but we don't want to necessarily do any processing on it here. Though you could, if there was processing you wanted to do on every row, you could define it here and return the changed rows, and data coming in would be treated exactly the same, regardless of which source it's coming from. And then we have our output node, which is using the context that defines our output text file, because we're outputting this in JSON. And then we have a sort of custom JSON loader. So Bonobo does offer JSON loaders and CSV loaders, and I think it's all file system related. There aren't any external database connections, but data in files in different formats it can read. But the actual file that we are working with, it has the same type of data as we're getting from the API, partly because it is stolen. It's taken from that same source. Well, a different source with the same schema. But we actually got it back as a sort of HTTP response. So it's split up into the response and the actual data, like the response code, and then the data in separate pieces. So this is a sort of custom JSON loader. It doesn't use their own JSON loader, because if you use that, you just get back those 2 sections, response code and response, which are not in the same schema as the data that we're getting back from the API. You have to go a level deeper. So this just does that. It opens up the file, and then it yields lines one at a time from the subsection of the document that we describe. And then in our graph definition, we create our graph, and this time we have 3 chains, because this is how you do branches. There was a 4th that printed it out, but that file contains 1,000 lines, and no one wants to sit here for that. To all print illegibly in the console. So what we're doing, we have our chain. This is actually the output chain. What it does is it starts with input none because you don't want it to do anything until it gets data from the other nodes. So it doesn't have data coming in on its own as a subsection of the greater graph. Other nodes will have to write data to it. And it has the node normalized, which does nothing, as if you remember, and then it has the write out to file node. And then under that is our first chain, which extracts data from the API, limits it to some smaller number, and then outputs it to normalize, where it then gets written to the file. And then under that is another one, which takes our data from the file. It limits it again to 10 this time, and outputs its normalized. It has a name because we wanted it to, there's a line that I removed, but we wanted it to connect nicely to the print node, which we just print. But defining, you don't want to duplicate the work that the JSON loader is doing. It would have created a new node of the same type that would do the same thing, duplicating the work. So you name it to make sure it connects them properly. And that's it. So we can now run this. And you can sort of see it actually does change in real time as your steps are run. And you can see the JSON loader that loads from the file got out 1,000, but it limited from 1,000 to 10, and then put them in normalized where they combined with the 5 from before from the API. So there are 15 in our file output.txt. So it's a whole bunch of data. But if we scroll down to the bottom, we can see that there are exactly 15 entries in this file. And then we can also, once again, look at the graph for this new one. But it's the same command. We've just substituted myetl.py, which is the name of this file, for tutorial.py, which was the name of the tutorial file. So it outputs our graph. We can then go look at the PNG. So all of these graphs start with, this is the input node that we defined as none for normalize. Otherwise, that would have been an arrow going from here to here. But you can see branches, you can see, well, not actual branches here, but you can see the merge here, and you can see that it outputs to the file. Are there any more questions? Oh, one thing that I want to mention is that the operation that's going on here is not a join. Because Bonobo uses streams, in this case, streams of rows from the API representation and from the file. If there were duplicates, they would get loaded into the output just the same. So that would be something you want to watch out for. All right, that is what I've prepared for today. In future, you can expect more involved demos for these, since there won't be a bunch of research that needs to happen into the ETL tools specifically. But now it's open for questions, and then, well, I'll give it a little bit of time, but once we're done with questions, just a little bit of time for open discussion if anyone has anything they'd like to bring up and talk about.
That was great. Thank you. So the question I have is, which is your go-to when you need to use some ETL in Python?
I really like Pandas, though I've been thinking about going to use more PySpark, because I used to do a lot of scikit-learn and like TensorFlow, and those interact very well with Pandas. But I've been learning more recently about Spark ML Um, and so having your data represented or in Spark already could be an advantage for pipelines using that.
That makes sense.
Yeah, a lot of the Spark ML libraries and models and all that sort of stuff are set up to use Spark data frames already. And while there is sort of a conversion process from Pandas to Spark that you can use, they're generally similar enough that if you can put it into Pandas, you can put it into Spark, and adding extra steps is sort of unnecessary.
Pipelines for TensorFlow. So the question I was asking before about transforming deeply nested JSON structures, that are schemaless, or maybe the schema is changing. You don't know quite what it is. So if you're building an ML pipeline, oftentimes the transformations aren't quite kosher for direct input to TensorFlow, say. Especially if you're using, like, say, Spark JSON method. What's your typical strategy in those cases? Like when you have very complex data structure, of unknown schema.
Yeah, I think generally that's pretty complex, like regardless of how you go at it, just because like anything that uses schema is set up to stick to it pretty strictly. Um, so I think, yeah. So Pygram ETL might have stuff to deal with that sort of stuff. It's supposed to have the fact tables, internal data representation, can represent static and changing data. But I don't know if the schemas will be able to accommodate that. Um, and then generally, I would just sort of go at it. If there's data that can be extracted in sort of a table format, um, and then later on sort of sift it out into proper representations. So empty rows get dealt with and that sort of stuff later on. But it's hard to say that there's really a good solution to that problem.
It's pretty tricky. I was looking for like a recursive solution. One thing I was wondering though, let's say that just for argument's sake, in your ETL workflow, you're going directly to Cassandra with the schema lists. In this case, what would be the reasons why or why not going to Cassandra first versus Spark with schema list transformation? Have you ever seen a use case where that would make sense?
I'm not entirely sure. If you have schema list data, it's hard to find a situation where Cassandra plays nicer with that than Spark would. I guess theoretically possible. Maybe if you were like uploading graph data, something that Spark wouldn't necessarily deal well with. But like if you use DSE graph, you could then take the tables out of that and have something moderately like usable. But yeah,
So
I think
in that case, I was wondering, for those who are, stay up with Cassandra more than I do, which isn't much, has the Spark Cassandra connector that I think DataStack still maintains, have they done any further work in supporting the connector for, graph data structures that are stored in Cassandra?
I know that the DSE version of the Spark Cassandra connector does indeed like work with graph data. You can use it to do graph manipulations, creating and removing and that sort of stuff. But if you ended up with the Apache Cassandra 4.0 version of the Spark Cassandra connector, you wouldn't be able to use it to do the same thing. So I think they are working with it, but I don't know if there's recently been a whole bunch of progress or not. All right, does anyone else have insight or data engineering conversations that they've been wanting to have?
No, this was good. Thank you.
Yeah, thanks. Ciao.
Yeah, and Will, since you are presenting next week, do you want to kind of give a preview into what the topic will be and what you'll be covering? Oh, let's see.
I think he might have just had to run.
Okay. Yeah, that's fine. No problem. But yeah, since we have about 15 minutes, if anyone that's on wanted to potentially ask the community that we have here any questions that they have about data engineering that you potentially are stuck on or want to get insight into, feel free to speak up. This is a community, so go ahead and ask any questions you feel necessary.
Hi, my name is Anant. I'm new to the community. I would like to ask you a question about database migrations. What is there any tool you use for that, for version control and database migrations?
Yeah. What databases do you generally work with?
Redshift or PostgreSQL mostly.
Okay. I know with Postgres, there are some tools that you can do like your export as JSON. And then depending on, I'm not as familiar with Redshift migration and exports, but there are some command line tools. I forget exactly what they are, but you can essentially designate your source and your destination database. Let me see if I can find it. I think PG Loader was the one. I think it's a Python tool.
All right.
That might be something that you could look into for Postgres.
I look into it. Thank you.
Or it might be an MP or npm package. I'm not entirely sure. Yeah, it looks like PG Loader was made with Python. So yeah, if you're interested or if you're looking for doing migrations with Postgres, PG Loader might be something that you could take a look into.
All right. Thank you.
Hey, Obi. My name is Ketan, and I want to know because you were showing this presentation, and could you give us some picture about this library which you use for the fact and dimensional table?
Sorry, what?
The fact and dimensional table, the one library you showed in your presentation.
Oh,
I think it's
Pygram ETL.
yeah, something.
Yeah, so it has the internal data representation, fact tables, and it's sort of, where's that graph? Sorry, give me a second. They have a sort of example graph where data is sorted into a number of different tables coming in from different data sources. Here we go. So you can see they have a sort of, this is sort of a representation of a fact table. And then it contains different dimensions of different data that can be represented as tables. And then also if you have, what do you call it? If you have something, if you have changing data, you can snowflake them out into a number of different tables, and that's all within the single fact table object.
Yeah. And we can use with Kimball table as well, like the Kimball thing. What was it called? I don't know. But this is for Snowflake, I believe.
Yes, or part of it is.
Yeah.
I think it was, some of it is static, these two, and then the main fact table representation here. This is the changing data, and it gets snowflaked out.
But yeah, my question is, can we use it with Kimball model as well? Because this is the example for Snowflake. But is it possible to use with Kimball model as well? For example, star schema.
Yeah, sorry, I could not tell you.
Okay, no worries. I will check it out. Thanks.
Alrighty. If there's nothing else, we'll go ahead and wrap it up for today. If you have, if you want to catch up on the older data engineers lunches, we have them recorded, and you can find them on our YouTube channel, youtube.com/AnantCorp. And there's also a playlist. So if you just Google for data engineers lunch YouTube, you should be able to find the playlist with all the videos. And yeah, that will wrap it up. Thank you everyone for coming. Great questions. And we will see you all next week. Same time, same place. Take care.